Welcome back to another Pewak YouTube video. And today we're going to take a look at longest substring without repeating characters. So let's take a look. Given a string S, find the length of the longest substring without repeating characters. So we have example 1, S equals ABC, ABC, BB. Output is 3. Explanation, the longest substring is ABC with a length of 3. Example 2, we have S equals BB. I think that was 5 times, and we have 1. And then the answer is B with a length of 1, right? And then we have PWW KEW. It's pretty close to Pewaukee in my opinion. And the answer is WKE with a length of 3. And we have a little note here. Notice that the answer must be a substring. PWKE is a subsequence and not a substring, which makes sense because we shouldn't be able to use that P from the previous when W is repeated twice. So let's start. What is the problem really asking? The problem is asking us to find the longest sequence of continuous elements. I'll say slash characters. Characters. The longest sequence of continuous elements slash characters that are unique. All right. So let's think of some examples. Let's say example. Let's say letters, digits, symbols, and spaces. So we have all types of ASCII values. So I'm going to say A, B, 1, 4, 6, %, 8, C. So we can see here we would have A space B 1, and then we have 1 again. So this would be 4. We'd have 4, and then we would say 1, 4, 6, %8C would be 6. So we would say answer was 6, like so. Let's take a look at another example. We would say, or could say, A, B, D, E, F, A, C, G, star. So we have A, B, D, E, F, that's 5. 5, and then we have 4. The answer is 5. And let's do one more example, just so that we understand. Let's do, so the length can be 0. I guess if we had 0, then we would just return 0. That's a strange one. I don't think it'd be at least 1 as a minimum, but perhaps not. So let's think, B, say percent, B, C, G, Z, capital B, A, we'll say D again. So we have 1, 2, 3, 4, 5, 6, 7, 8. So let's see if capitals are different. They should be different. So answer 8. So let's actually just use the test. Let's just test it here. So let's just return 0, and then let's just run that code and then obviously fail it, but that's fine. And then I would like to test what happens if we say B. I'm just gonna say, or I could say percent D, C, G, Z, B, A, D. You should get 8. 8. Alright, fantastic. Hopefully my notebook isn't in the way, but the expected answer for that is 8. So basically it just needs to have a different ASCII value. ABC, ABC, BB. So let's just make some observations now. So observations. We could think that, could this be done in ON time? I don't know if we'd have to keep track of the previous elements. Could we just use ON space complexity? Well, we could think of something like that, but then if we wanted to use in, that would be a problem unless we used a dictionary. If we're doing in Python today, then using a dictionary would be quite simple. I guess if we're using Java, we could say a hash table, but okay, let's just make general observations. So keep iterating while the ASCII value isn't repeated, right? So, I'm trying to think. I feel like this is an ON solution, but can't seem to figure it out right now. But store the max when an ASCII value, when a ASCII value is repeated, right? So we want to see if the length of that kind of string has been, or what that length is, and if it's greater than the maximum length. And then what's another thing we could do? What's another thing we can observe here? I'm honestly not sure. Would this be, let's see, use a dictionary, just say, or easy access perhaps? So something as like char or character ASCII as kind of the dictionary of elements with a key of character and a value pair with value being ASCII, the ASCII number, or what else could we say? Honestly, I think that's the general idea. So I think a dictionary is better for faster access, or we could use a set. We could use a set. Use a set and okay, use a set for every iteration. Try to add the element to a set. To a set. Yeah, I don't know. I'll let you know in like a bit. I don't know. I'll see. I'll see. Just keep like 15 downstairs. Okay, excuse me. So let's try and add the element to a set. If the length doesn't change, then there's a duplicate. A duplicate, right? So, that's the general idea, I think. So, small steps. And so step 1 is going to be initialize a set, and a max value, a max value, iterate through the string. So iterate through the string and try to add to set if length doesn't change. There's a duplicate. Check if the set length is greater than max length and set, or let's say empty the set. Okay, now let's translate that to code in our programming window here. So step one, init a set and a max length. I'm going to say set. Okay, that's a thing. I'll just say set equals set. Oops. Max equals 0. Iterate through the string. So we're gonna say for I in range len s if s. What am I checking? Oh wait. We're gonna say step 2. Step 2, iterate through the string. Step 3, try to add to set if length don't change. There's a dupe. So I'm going to say length equals len set, and then I'm going to say, oops, this is supposed to be set, and then set dot append si if length not equal to len set. Again, now there's a dupe, so we'll say there's a duplicate. So then we want to say set equals set, and then we want to append the what is it, dot append. We want to append that character again because it's going to be the start of a new substring. We're going to say if len set, we'll say without those extra parentheses, you don't really need them. Len set is greater than max equals len set. And then, yeah, then that's it. Return max, I believe. See if that works. Set has no let's see. Get the left. Can we add? Uh-oh. I don't know if you can add. Add to sets. Can you do that? Set. Add. Oh, it's just add. Oh. It's not appended, it's just add. add, and then add, and let's see, 2. Let's print, let's see, um, print the length, let's see, so 0, 1, 1, 1, 1, 1, 1, it's always 1, why is that happening? Should be, so it's 0, okay, then you add si, which is a, print si, look, what's the problem here, let's see, ABC, ABC, BB, alright, fantastic, we're getting the right elements. So try to add to the set. If the length don't change, there's a duplicate. And then we want to check, and then we want to say set as a new set, and then add the same thing. Let's just print the set. Let's try and do that. Let's see what happens. So we have A, then we have B. That's interesting. Oh, wait a second. Length equals the length of the set. Oops. Okay, let's just check. Actually, let's check our special test case that we made. So B and GC, GZ, B, A. Let's see if that works. Uh-oh. 0. What happened? um, so B, we have ampersand B, then D, ampersand B, then... Oh, I said A. I think I meant to say D. Wait, but then... Oh, wait. But even if we have something that is unique all the way through, then we want to say, here we want to say or the I equals len s minus 1 here, and then that should return 9 like how it's supposed to. Okay, or end. So or end of iteration. And we want to check that. So that's what we're gonna do, and then I believe, let's just make D right here, so we get to run into that duplicate. Perfect. I actually want to see something. I want to see the add complexity. I want to see set add complexity. Is O1. Oh, nice. So this is a ON solution. Which is very nice to see. And it fails. Oh, man. Okay. Oh. Okay. This might have to be ON squared then. Oh, shoot. Shoot. Okay, I see what this is saying. Alright, Speedwalker from the future here. I just wanted to give a quick explanation and just make a cut in that video so it's a little bit shorter. So let's just explain what I did here. So step 1, we just make all these variables, and we're going to use a while loop here so that we can change the index, basically because of the test case that was what was it, DV, DB or F. So in this test case, right, we had a start counter or the start index, and then if we say, okay, we reach a duplicate, then our start index needs to be that V. It needs to be on the V instead. That's basically what I did here. And using a while loop, it's easier to just say, okay, if we run into a duplicate, then here I just say I is equal to the current start, which is initially set to 0, right, because it's the D element, plus the 1, so then it's set to B, right? And then basically when we run the loop again, then this is going to be called, and it's going to say if not set, which means the set will be empty at that point, right? Because we just started at v. Then we are going to say the current start is now I, which is just v, or which is 1. It's index v. In theory here, you could just say cur start plus cur start plus equal 1, and in reality you wouldn't actually need to say this. Let me just make sure that works. Okay, so yeah, you wouldn't need to say that, but you could just say cur start plus equal 1, and then you would just keep going on iterating through the list. All right, back to the end of the video. Wow, that's slow. That's so slow. I didn't think it'd be that slow. How did others do it? Let's take a look. I'm somewhere off the freaking galaxy. Char equals dictionary. If SI in char and start is less than or equal to start equals +1. Oh, where the SI is located in the char array. Char, wait. So else this means that there's duplicate SI in char and start is less than or equal to char SI? Frankly, I'm a little confused. Max len equals max len I minus start plus 1. Yeah, I didn't understand that. Huh. Well, I mean, we found a solution at the end of the day. Wasn't very optimal, but I thought the ideal way was to use sets, as I've seen in other questions in the past other people use, but perhaps in today's example it was not great. Let's try and submit again. Let's see if the runtime goes down a little bit. I don't know. No, it does not. But anyways, thank you for watching. Please like, subscribe, and comment your favorite thing about the video or something or a way I could just code better. That'd also be nice as well. Would like to learn. Thank you for watching. Peace.